Hello again. Welcome back. We're going to start chapter 2, and we'll be graphing categorical data. Then in the next chapter, we'll talk about graphing quantitative data. In one of our last videos, if you remember, we talked about the differences between those two. So if you missed that video, go back and look at that one before you start this one. So 3 rules of data analysis is make a picture, make a picture, make a picture. Things may be revealed that are not obvious in the raw data, and these will be good things to think about. Important features and patterns in the data will show up. You also may see things you didn't expect, and the best way to tell others about your data is with a well-chosen picture. There are 2 main types of graphs that we'll focus on for categorical data. There's bar graphs or a bar chart, and a pie graph or a pie chart. So bar graphs are as you can see, there's a couple different kinds, right? We can have a frequency or a relative frequency bar graph. The frequency bar graph displays the counts for each category. So in our frequency bar graph below, you can see that around 300 or more people fly first class. This is a bar graph of airline tickets sold. Slightly fewer, right, fly second class. Much more people, around 700, fly third class, and over 800, almost 900, fly crew, or this is probably economy. So the relative frequency displays the proportion of the counts. And we'll actually talk about how to build this in one of our next videos, but you can see that the bars themselves have mostly remained the same. The only thing really that changes is our x-axis. It's gone from counts to proportions or percentages on that vertical axis. You can also do a stacked bar chart to incorporate another category, right? So we have the category down here, liberal, moderate, and conservative. So this is a category, right, of voter registration or voter identification, party affiliation. And then the color of the bars themselves, right, we have 3 distinct colors, this gray, blue, and red. So we've incorporated a second category, right, of diet. Gray is vegetarian, blue is omnivore, and red is carnivore. So you can see here in one chart that only about 10%, if that, of liberals are carnivores. About 80% of liberals are omnivores, right? From this about 10% or so all the way up to almost 90%. And then that last 10% are vegetarian, right? Notice these all add up to 100. All right, so then we have pie graphs. Pie graphs are good when you're interested in parts of a whole. Pie charts show the whole group of cases as a circle, and they slice the circles into pieces whose size is proportional to the fraction of the whole in each category. And they can also be displayed as a frequency pie chart, which are counts, or a relative frequency pie chart, right, which are proportions. Here we have a frequency pie chart, right? We see counts. Looks like that same bar chart that we looked at a couple slides ago was also turned into a pie chart here. So if these were all of your ticket sales, maybe you're an airliner, right? You can see the parts of the whole being all of your ticket sales, and these parts being the different classes that people have bought. So think before you draw. Our first rule is to make a picture, but what kind? Knowing when to use each type of graph is critical for step and data analysis. That decision depends in part on what type of data we have. It's important to check that the data are appropriate for whatever method of analysis you choose. And before you make a bar chart or a pie chart, always check the categorical data condition, that the data counts or percentages of individuals in non-overlapping categories, which we've talked about before. Don't violate the area principle. Some people might like the pie chart on the left better. It's actually harder to compare the fractions in this one, right? It's not as easily seen which piece of this pie chart is the biggest or the smallest. Could you really tell me if the third class, this purple piece right here, was actually bigger than the crew piece? Comparatively, can you really say if the first class is bigger or smaller than the second class? It's kind of hard to tell from this angle. Whereas here it is easier to tell, right? Crew, you can tell, is the biggest, third is the second largest, and first and second are still pretty close together, but it looks like first might be slightly larger than second. Keep it honest. This plot of the percentage of high school students who engage in specified dangerous behaviors has a problem. Can you see what it is? It's right down here. The problem is that it doesn't add to 100% because of the overlapping categories. The area principle is violated because the blue section looks like less than half, right? So if this is truly 50% of these students use alcohol, then this line should be straight down the middle, right? Cutting the circle or our pie exactly in half. And then also if you add 50 plus 31, that gets you 81 and a half. If you add 26.7 to 81 and a half, you're well over 100%, right? Which is why this chart is thrown off. So requirements for a graph, make sure you title your graph. A hint, this is sometimes the most item missed on the first test. Label each axis of a bar graph and label each sector of a pie graph. Label and use appropriate scales and obey the area principle. The widths of each category in a bar graph should be equal. So basically the space in between your bars, the size of your bars themselves should also be the same size, roughly. The heights in a bar graph should match the scale of the data. All sections in a pie graph should total 100%, and each section in a pie graph should match the scale of the data, right? So it should, whatever percentage it says it is, it should look like that percent. If it's 50%, it should be exactly half, no more or no less. All right, so do you think there's anything wrong with this bar graph or bar chart? We have the answer right here. There's no title up above our chart. We have no spaces in between our bars. There's this false depth, right? That really doesn't mean anything. It's maybe a cool 3D effect, but it's not necessary. The labels for the bars are on the x-axis are oriented differently than the x-axis itself, right? So they're saying that ice and therapeutic exercise, hydrocollator, etc., so on, are reading vertically, which may lead to confusion, right? You might think that ice has something to do with the vertical axis, right? But in reality, ice is actually the category of this bar along the x-axis. All right, so let's look at an example of a bar chart versus a pie graph. So here we have number of students, right, who have made certain grades in our class between A, B, C, D, and F. So in each of these, you can see fairly easily that C's made up the most grades. It's a little harder to tell, sorry about that. Maybe who got more D's than F's, or what color is this blue color? F's and A's, right? You can tell B is slightly larger. But here on the bar chart, right, you can pretty clearly see that there were slightly more A's, right, than F's, and even more B's than A's. All right, so next we'll talk about frequency tables. A frequency table can be used to build either a pie chart, or a bar chart. You can see in your first column, you simply have your categories, right? This question is asking how many of each kind of pet have you had, right? So we have dog, cat, fish, bird, or other. And here, if I were to go around and ask the class, if we were in person, right, how many of each kinds of these animals you had, we could record your numbers here, add them all up, and get frequencies for our entire class. And we could take this another step forward and create a relative frequency table. Let's say we filled this out. Oops. And we had only one of each, right? So one dog, one cat, one fish, one bird, and one other. In the relative frequency column, and we'll do an example of this in our next video, we would simply start with this first number here, this 1. Let's see, so we have a 1, 1, 1, 1, 1. This 1 would come over here. And then in this next column, we would simply add this 1 here and this number here. So we take this 1, we would also add this 1. We'd add those two together for a total of 2. And likewise, we would take this one over here. We would move our 2 down, add those two together, and we'd get 3. And we'd continue this process till we got to the very end. So 1 plus 3 would give us 4. And the end, we'd have 1 plus 4, which makes sense because if we only had one student with each kind of pet, there were 1, 2, 3, 4, 5 different categories. So this totals the total number total frequency that we had. We could do one more step and create a cumulative relative frequency table. So from our last relative frequency table, right, we had our frequency column and our relative frequency column filled out. So now all that's left to do is to fill out our cumulative relative frequency. Oops, I messed up. Sorry, our relative frequency is not the sum of these, but it's actually the proportion, right, that we saw. So this would actually be 1 divided by our total, which would be 0.20 or 20%. These would actually all be the same, right? We saw that we added these up and we got 1, 2, 3, 4, 5. Right, so each frequency was 1 out of a total of 5. So the relative frequency for each is 1 divided by 5, which is 20%. And now we could come to our relative frequency, cumulative relative frequency. Cumulative meaning we add. So we'll take our first 20% here. And that's all we'll leave here. And then for our next column, we'll add that 20% plus the next 20%, and we'll get 40%. Then we'll take this 40%, we'll add it to this 20% to get 60%, and so on and so on. So take this 20% plus now our 60%, and we'll get 80%. And lastly, we can add 20% to 80%, and we'll get 100%. We should always get 100% when we last finish here. Sorry for that confusion.